There are so many substances which exist in different form. Even in the fact that their chemical constituent is same, still they exhibit different characteristics. Some materials can differ in their physical state. They physically might seem different, but chemically they behave similarly, or their chemical constituent remains to be same. Like even carbon has two different states, like we must have seen isotope. Even there are varieties like iron. Iron has also a varieties, alpha iron, beta iron, gamma iron. So one substance can exhibit different properties in different forms, and that's where we call allotrophs. Allotrophs is actually the property of any substance which actually show you that a substance can exist in different forms. They might exist in different forms, but if you see their chemical constituent, if you see their mechanism, if you see by zooming their all the constituent particles, their forming particles, they will be same. In the case of carbon, the same thing happens, because carbon exists not just in one form but in many different forms. Some are actually very useful for us, some are pretty cheap, and some are dangerously very high, that it costs very well, like diamond. But coal, which we generally use in our cheap prices for cooking our food. So let's see some allotrophs. What is allotrophs? Allotrophs means a substance which exists in different forms. A substance that exists in different forms but having the same chemical compound or having the same chemical constituent particle. Okay, so here we can say that it can be stated as if any substance or element exists in many different forms, that is physically different, but at the same time their chemical constituent remains similar, that is chemically same. So allotrophs means a substance can exist in different forms, still maintaining the proper arrangement of the same atom or the same molecule. In the case of carbon, we can see carbon as coke. In the form of graphite, in the form of diamond, in the form of fullerene, and also in the form of carbon nanotubes. There are varieties in which carbon can exist. Some are even artificially created in lab, like carbon nanotubes and fullerenes can be artificially created in lab, and they are actually 5 times more stronger than normal steel. So the allotrophs exhibit property differently because their physical state seems different, no matter what their chemical properties, if it's common. So coke has the same constituent particle, carbon. Graphite has the same constituent particle, carbon. Diamond has carbon. Fullerene and tubes has carbon. But since they appear differently, coke you can break easily, graphite you can break easily and it is conductive also, but diamond you can't break it easily. and fullerenes and tubes that we are using in the manufacture of some very high quality modernized weapons and in our electronics, like all those different electronics and very highly sophisticated what it is called, just leave it. There are so many fields in science, in making different types of parts in different machines. We use carbon nanotubes and carbon fullerenes like Buckminster fullerene in different ways. They are also being developed in Japan to prepare a rope that will connect International Space Station directly to the Earth, and so we can use that rope as a lifting cable so to send different stuffs directly to the ISS without using any rocket, just like a lift. So you can see how powerful tubes and fullerenes can be. You must have seen soot. If you have a lamp in your home or a candle, then you must have seen a black layer which is formed on the upper surface where you burn that candle. That soot rug that you usually call has that fullerene. Carbon compounds can exist in different allotrophs easily. So let's learn that separately. Let's remove coke because it has just one basic property, carbon, with some different impurities. So we won't include coke here. Let's see graphite. In graphite, a carbon connects with 3 different carbon atoms. So here carbon share one of its electron and since we all know that carbon has 4 electrons in their valence shell. So by sharing 3 electrons, 1 electron remains unshared. This 1 electron is what makes graphite look like opaque. Opaque, first thing. Second, conductive. The melting point of graphite is 1800 Kelvin, melting point, and its density range around 2 to 2.25 gram per cubic centimeter. That is the density. So these 4 properties are actually telling you what happens when just 1 electron gets unshared. What is the difference between graphite and diamond? In diamond, carbon share all of its 4 electrons, but in graphite it shares just 3 electrons, and just by leaving that 1 electron causes this mega difference between the graphite and diamond. In diamond, carbon actually connect with 4 different sides by carbon. So carbon actually uses all of its 4 electron to get linked with another 4 carbon atom. In this case, carbon left out from any electron, any unpaired electron or any valence electron in the shell. In the case, as the diamond share all of its electron, it becomes transparent. First of all. Second, it becomes very hard. Hard so that its density ranges between 3.5 gram per cubic centimeter. You can see the difference, 2 to 2.25 and 3.5 gram per cubic centimeter. See how hard its density is of diamond. And its melting point also increased so much. That is 4000 Kelvin, and it becomes a perfect insulator. Because conductive means it must have some free charges. If they don't have free charges, then how can diamond can become a conductive? So the difference between graphite and diamond is graphite has 3 electrons being shared and 1 unshared electron, and diamond has all 4 electrons being shared. That 1 electron changes everything, whole scenario gets changed. That's why graphite can be easily available in the form of pencils, but diamond is available actually in high, very high in rich people's home, or in the goldsmith's shop, like in our shop. Just leave it. Just the thing is here, they both vary from their density to their melting point to their appearance, but chemically their constituent is same. That's the power of allotrope. That's why their uses are completely different. Whether on one side graphite is being used in the form of pencil or as a conductive material in the form of different graphene layers that we actually are making, for what scientists have already got Nobel Prize for that. So generally graphite can be a conductive and can be used to make ultra sensitive devices, ultra sensitive capturing devices or signal processing devices. Whether on the other side diamond is used as a crusher, as a polisher, or as an ornament. So there are varieties, and that's the variety between these two different candidates of the same element, that is carbon. Okay, so up to this we are done, and so let's start the next thing, next topic, and that topic is already been taught in the last video, and that was what? Catenation. Let's see catenation once more. Catenation, it is the ability of carbon atom to connect with other atoms simultaneously. Why? Carbon can connect itself with any other atom, whether it is hydrogen to make hydrocarbon, or whether it is oxygen to make carbon dioxide or carbon monoxide. There are varieties of different compounds, whether inorganic compound or organic compound, where carbon connects itself and to form something new. Initially, carbon was thought to present in both form, organic and inorganic. Inorganic and organic. Carbon is actually present in both places. In the organic form, carbon is believed to have evolved with all those different elements like nitrogen, hydrogen and phosphorus. Carbon, nitrogen, hydrogen and oxygen, and one last element, that is phosphorus. These 5 elements are called the real God because they have created different molecules that were called conservates or biomolecules that finally led to the formation of simple cell or simple types of life. All the RNA, all the DNA, that's the nucleic acids, have the same one common component, that is carbon, along with all these 4 elements. This can't be, amino acid can't be possible without the help of nitrogen, without the help of oxygen, without the help of hydrogen, without the help of carbon or phosphorus. So look, whether it is organic or inorganic, carbon is actually present everywhere. It is omnipresent element. The thing here is now about catenation. Carbon generally have the ability to link itself with carbon, or it can connect itself hydrogen to form methane, which is a biomolecule too, can connect with oxygen to form a carbon dioxide. There are varieties of form that we will learn in alkyl group and in alkane, alkene, alkyne form. Okay, in single bond, in double bond, in triple bond.